This video is about reflecting an image over a line. So a reflection is a rigid motion transformation where each point in a shape appears an equidistant on the opposite of a given line. This line is called the line of reflection. It's also thought about as flipping over a line with your figure. So before we start doing reflections, we need to review graphing horizontal and vertical lines. So if you have an equation x equals 7, that's a horizontal line because 7's on the x-axis, and then I want a line that passes through that point, so I get a vertical line. Y equals 7. Any y equals equation is a horizontal line because I have 7 on the y-axis. I'm going to make a horizontal line to pass through that point. Now, these ones are interchangeable. Y equals 0 and the x-axis is going to be our horizontal axis. And x equals 0, or the y-axis, is going to be our vertical axis. So let's look at how do we reflect over a vertical or horizontal line. So what you're going to do first is you're going to use a dashed line to graph the line of reflection. So in this case, our line of reflection is x equals -2. So at -2, I'm going to draw a dotted line onto my coordinate plane. Then what I'm going to do is at each vertex of my picture, so at A, B, and C, I'm going to count how far am I away from my line of reflection and then use that number to go the other side of the line. So A is 1, 2, 3, 4, 5, 6 away from the line of reflection. So I'm going to count 6 the other direction. 1, 2, 3, 4, 5, 6. So this is A prime. Then I'm going to do the same thing with B. So B is 1, 2, 3, 4, 5, 6, 7 away from the line. So I'm going to go 7 the other direction. That's B prime. And then last C is 2 away, so I'm going to go 2 the other direction and place my last point. Then I'm going to connect these points, and now I have my image. So this is my new figure that happened after I followed the reflection over the x equals -2 line. So let's try a couple more. Number 1, reflect hand over the y-axis, or x equals 0. So the y-axis is our vertical axis. So I'm going to draw my given line. I'm going to plot the points they give me first. So H is at 2, -3. A is at -3, -5. N is at -4, -1. And D is at -5, -4. So I'm going to connect those points to form my original, and I'm going to use those points to make my reflection. So in order to make my reflection, I want to count how far is N away from the line of reflection. So 1, 2, 3, 4. So I'm going to go 4 the other direction, and I now have N prime. D, I'm going to count, it's 5 away from my line of reflection, so I go 5 the other direction. A is 3 away from the line of reflection, so 3 the other direction. And H is 2 away from the line of reflection, so 2 the other direction. Then I'm going to connect my 4 points, and now I have my image. Number 2, reflect arms over the x-axis. So the x-axis is our horizontal axis. So I'm going to mark my line of reflection with my dotted line. I'm going to plot my given points. So A is -2, 4. M or R is 5, 5. S is, or M is 3, -3. And S is -1, -2. Now notice that this time some of my points are on the top of my line of reflection and some are on the bottom. This is okay, so when we do the line of reflection now, they're just going to switch spots. So if they're on the top, they're going to move to the bottom. If they're on the bottom, they're going to move to the top. So A is 4 away from the line, so I go down 4. That's A prime. R is 5 away from the line, so I'm going to go 5 down. M is 3 away from the line, so I go 3 up. and S is 2 away from the line. And then I just connect my points again, and it's okay that my shapes overlap a little bit. Number 3, reflect over the x equals -3 line. So x equals -3 again is a vertical line. So I'm going to look at each point and go to the opposite side of the line. So A is 2 away from the line, so I go 2 the other direction. I is 5 away from the line, so I go 5 the other direction. And R is 1, 2, 3, 4 away, so I'm going to go 4 the other direction. Once I have my 3 points, I'm going to connect my line. Pause the video and try number 4 on your own. So number 2, once you complete your reflection, your image should look this similar as mine. K, we ran out of coordinate space, so just kind of estimate where K would go. Now, the other type of reflecting that we could do is over the y equals x line, which is a diagonal line. So y equals x, think back to algebra, starts at the point 0, 0, and has a slope of 1 over 1. So we're going to go up 1 over 1 all the way to the corner for our diagonal line, and then all the way down to the other corner. Now, in order to graph, we're just going to make up a couple of points to try it. We have, let's try 2, 8 is A, B is 5, -4, and C is -8, -8. So what you're going to do is you're going to identify the coordinate. So A is at 2, 8. In order to get the reflection over the coordinate, you're going to switch the x and y coordinates. So A prime then would now be 8, 2. They keep the same sign that they have. So 8, 2, this is my A prime. B is currently at the point 5, -4. So my B prime would be -4, 5. Because all I'm doing is I'm flipping the x and the y. So I would go to -4, 5. This is my new B coordinate. Now, C is on the line of reflection. So anytime your point is on the line of reflection, it's going to stay in the same spot. So 8 is going to stay at -8, -8. So let's try reflecting over the y equals x line. So I'm going to draw in my line of reflection for y equals x. All the way across my graph. And now I'm going to graph my reflection. So T is currently at the point -5, 4. So to get the new point, we're going to switch the order. So instead of -5, 4, our point is now 4, -5. So I'm going to go to 4, -5, and that's T prime. R is on the dotted line, so it's going to keep the same point of 2, 2. Y is at -1, -9. So we're going to switch that, so it's now -9, -1. And then I'm just going to connect my points in order to draw my image. Pause the video and try number 6. In number 6, once you perform your reflection, you should have got H was at -4, 1, A prime was at 2, 4, R prime was at 3, 9, and D prime was at -9, 5. Now we're going to go the opposite direction. So our graphs are drawn for us. We need to figure out the line of reflection. In order to find the line of reflection, it's going to be in the middle of our points. So we're going to pick 2 points and figure out where the middle is. So one of them is at -6, 9, the other one's at 2, 9. So we want to find what's in the middle between 2 and 9, because I know my line needs to go somewhere over here that's in the middle of these objects. So between -6 and 2, we can add those together and divide by 2. So -6 plus 2 is -4 divided by 2, means my line of reflection is at -2. So we have x equals -2. Number 8, I'm going to pick 2 points. So I have one at 5, 2 and one at 5, -4. So I need to look at What is halfway between 2 and -4? So I can add those together and then divide by 2. So when I add them together, I get -2. Divided by 2 is -1. So this is a y line, so my line of reflection is y equals -1. Number 9, notice that it's not being reflected from left to right or up and down, but rather diagonally, so our line of reflection has to be y equals x. Number 10, which figure is a reflection of the original? So this is the original, and the line is just separating our reflection. So we either have to think about the guy flipping up or down or left and right. So if the nose is facing to the left, it can't be C because if we flip up and down, the nose would be facing the wrong direction. B is still the original image. A is the reflection because he's facing to the left driving, he's just now upside down with my reflection. In number 11, which image is a reflection of the original? So in this case, it can't be A because it's the same picture still. So now I have to decide between B and C. If I was to flip my face up and down, remember that your flower should stay on the same side. So it can't be C. If I was to flip it left to right, then the flower would switch positions. So B is my reflection. Number 12, using complete sentences, explain the transformation needed to move triangle OWL to triangle O'W', perform each transformation separately on the graph. So first, we need to get our triangle to look the same as the end result, which means we need to get this O flipped down to the bottom. In order to flip an image, remember that we're using a reflection. So first, we want to reflect triangle OWL over, and we want to flip it over a line always. So we're going to say over the line LW. So when I do that, I've now changed my triangle so that O is on the bottom. Once I've reflected, now I need to move the triangle. We move images by using a translation. So let's look at how would I get L from one part to the other part so that they overlap. I need to move, we would say translate all points of triangle OWL. We know that we need to move right up, so we're going to count how many using the grid line. So 1, 2, 3, 4, 5, 6, 7 to the right, and up 3 units. Please reflect the point over a given line. State which quadrant the image is in. So think about just drawing a line first of all. So if we have y equals 6, y equals 6 is a horizontal line. Our point 4, -3 would be somewhere below this line. So I need to figure out how much I would move to get to the line and then how much I need to go above the line. So first, to get to the line, we're going to look at our y coordinate because this is a y line. So how would I get from -3 to 6? I would add 9, which means I need to add another 9 after to get my new point. So if I added 9 to get to my line of reflection, my point would be 4, 6. I'm going to add another 9 to my y coordinate, so my new coordinate would be 4, 14. And that point is in the first quadrant. Number 14, reflect -2, 6 over the x equals 2 line. So x equals 2 line is a vertical line. So we have the x equals 2 line. So our original point is -1, 6, which on a coordinate plane would be located to the left. So I need to see how many numbers to get to my point. So it's on the line of reflection, and then how much to go to the other side of it. So because this is an x equals line, we're going to look at the x coordinate. So how would I get negative 1 to 2? I would add 3 and then add 3 again. So to get to my line of reflection, that point would then be negative 1, 2. I'm going to add 3 again. So my point would be, 2, 6. So then when I add 3 more to my x coordinate, because it's an x line, my point would be 5, 6. So this point is 5, 6, again in the first quadrant because both coordinates are positive. Number 15, reflect over the x-axis. So x-axis, remember, is y equals 0. So if my point is negative 6, 5, I'm located above the axis somewhere. So I need to figure out how to get to that line of reflection and then go across. So since it's a y equals 0 line, because it's the x-axis, I need to look at how do I get from 5 to 0? Well, I subtract 5, so then I need to do that to get to the other side. So when I subtract 5, I get negative 6, 0. Subtract 5 again, I get negative 6, negative 5. So my point would be negative 6, negative 5, because they're both negatives. This is in the third quadrant. Number 16, reflect over the y-axis. So the y-axis is our vertical axis. It's where x equals 0. And the point is 1, 7. So it's going to be on the right side of the y-axis, or the x equals 0 line. So how do I get to the x equals 0 line, and then how do I get to the other side? So to get from 1 to 0 as an x coordinate, I would subtract 1. So I'm going to need to subtract 1 again. So my point would be 0, 7. And when I subtract 1 again, negative 1, 7. So this would be at negative 1, 7, which is in the second quadrant. Number 17, reflect 2, negative 10 over the y equals x line. So remember that y equals x is our diagonal line. And anytime we have a diagonal line, the shortcut, where we don't even need to actually draw this picture, is that we're always just going to switch the x and the y coordinate. So when I switch them, my new point would be negative 10, 2, which is in the second quadrant.